Guys, so we're going to go ahead and we're going to start talking about number 10. So we're going to go ahead and we're going to do another one of these explain problems, which is super important for you guys to kind of be able to explain these blood type problems with the evidence in your Punnett squares, right? So our type A, right? And we're dealing with type O. So let's go ahead and let's read this question. It says, could two individuals with type O ever produce offspring with type A? Right? Explain with a Punnett square. So if you were a type O, pretty much you got to be OO, right? If you're type A, you got a couple options. You can be capital A, or a capital AO. Very similar to what we talked about last time. So we're going to go ahead and we're going to go through this, right? So if we go OO and OO, very clear, right? The only thing that we can get is individuals with O-type blood. So our answer in this case would be that we cannot have that individual. So this will be no, right? Individuals who are both type O can only have type O offspring 100% of the time, right? And then I'm using my Punnett square as evidence, right? Because I have this at 100%, right? And then I can also cite my Punnett square as well, right? Okay, so moving on, right? Is there a chance that a type O and a type AB couple could produce offspring with type A? So if you're type O, right? Let me go ahead, let me zoom in so I can make a Punnett square. Right, so I have OO and I have AB, right? So AO, AO, BO, and BO. Right, so that is pretty much my chances for my kids, right? So what is the chance that a type O and a type AB couple can produce offspring with type A, right? So if I look on here, right, I have two type A's, so I have 50% chance, right, for type A. Okay. So next one, right? So we are going to be going ahead and looking at this. It says a wealthy elderly couple died together in an accident. Soon a man shows up to claim their fortune, saying that he is their only son who ran away from home as a boy. Other relatives dispute his claim. Hospital records show that the deceased couple were type A, B, and O. Their claimant to their fortune is type O. Could he be their son? Explain your answer using the Punnett square as evidence, right? So I have the claim evidence reasoning set up as well as the Punnett square for you. So we're going to go ahead and we're going to look at this. So if they are type AB, right, we automatically know that this is the easy one. So that's AB. And if they're O, right, we have our O there. So it's it's the same Punnett square as the one above, basically. Right, so his blood type is type O, and they're asking us, can he be their son, right? So I'm looking on here, right, and I don't see any OOs going on or happening. So I'm going to say that this is not their son. This is not their son, right? So that's just my claim, and my claim is just my really, really short answer, okay? So now I'm going to go ahead and I'm going to cite my evidence, right? The Punnett square showed that, right, 50% of offspring is type A, while the other 50% is type B, right? So in me showing and talking about percentages and what type they are, right, I'm going ahead and using that Punnett square as my evidence, right? And now I'm going to go ahead and get into my reasoning, and I'm going to explain it in my reasoning. So being able to explain it is really like the meat of this, right? So it says, this is or is not their son, because a Punnett square proves ... Okay, so this is not their son, right? Because a Punnett square proves that all offspring will either be type A or B. I'm going to expand on it a little bit. The only way to have type O offspring is if both parents had an O allele, right? So that would be a complete explanation right there, right? So it says that this is not their son because the Punnett square proves that all the offspring will either be type A or type B. The only way to have a type O offspring is if both parents had an O allele, right? To make this better, I can go ahead and I can say that there's a 50% chance of A or B blood type. That would be the one thing that I would add, right? Because that kind of ties in what we wrote in our evidence, right, in there, and it adds some of that stuff in there, right? And then your reasoning really comes into that next part where we're talking about that O allele and where it comes from. Okay, so now we're going to go ahead and we're going to talk about this cattle deal. It says, in some cattle, a gene for brown hair and for white hair are codominant. Cattle with both brown and white hair have both brown and white hairs. This condition gives cattle a reddish color, referred to as roan. For each of the following, construct a Punnett square, giving the genotypic and phenotypic ratios of the offspring. So we're going to go ahead and we're going to start by creating our key. We know it's codominant, so that means that we have two capital letters and that both of them can appear at the same time, right? So we have our brown. So this will be our brown. Capital B, W, that would be our rowan. This will be brown plus white. And then our next one is our white one. So that would be our key. And that's super important to make a key, especially for those codominant and incomplete dominant problems. So now I have a red bool and a white bool. So I'm going to go ahead and cross a red bool. Oh, shoot. This is red. Cattle, brown, white. Yeah, this is red. Okay, so I have my red bull, which is going ahead. Red cow, my bad. Red cow, not red bull. Red cow. And then I have my white bull. So red cow, white bull. So I go ahead and I cross those. And they're asking me for my phenotypes and my genotypes. So I'm going to go ahead and I'm going to list these quickly. So BW and WW, where I have 50% of each. And they're asking me for colors. So I have my rowan, which are 50%, and then I have my white, which are 50%. Right, so those are our different, that is our cross for our first one. And then we're going to finish this up in the next one.